The National Electrical Code, or NEC, requires a motor disconnect within sight of the motor's location. The determination of whether a fused or non-fused disconnect is necessary depends on several factors. Firstly, consider motor overload protection. If the motor has built-in overload protection, it contains an internal mechanism that automatically disconnects power when overloaded. In this instance, a non-fused disconnect is sufficient. However, if the motor lacks built-in overload protection, an external motor starter or overcurrent protection device is needed to prevent damage from overloads, thus requiring a fused disconnect. Secondly, refer to NEC Article 430.110, which stipulates that fused disconnects are required for motors that are firstly rated over 1 horsepower, secondly, not protected by internal overload protection, thirdly, operating at more than 300 volts, and fourthly, located in hazardous or classified locations. Thirdly, local electrical codes may impose specific requirements for the type of disconnect, so checking local codes is crucial before making a decision. The motor disconnect serves two primary purposes: safety and overload protection. For safety, it provides a quick and easy way to isolate the machine from power during emergencies or servicing. For overload protection, fused disconnects protect the motor and wiring from overloads by interrupting power if excessive current flows. Based on the provided scenario, the drill press lacks built-in overload protection. Therefore, installing a fused disconnect is highly recommended to provide overcurrent protection. It's important to note that a qualified electrician should perform the installation, ensuring compliance with all applicable codes and safety standards. Now let's delve deeper into the technical aspect. The NEC, being a comprehensive standard for safer electrical installation, provides detailed guidelines in Article 430 concerning motors, motor circuits, and motor controllers. Understanding the specific requirements outlined in this article is crucial for ensuring a safe and compliant installation. When selecting a fused disconnect, several factors need consideration. Firstly, the voltage rating of the disconnect must match the voltage of the motor circuit, whether it is 208 volts, 240 volts, or 480 volts. Secondly, the ampere rating of the disconnect must be sufficient to handle the motor's full load current, in addition to any potential overload or fault current. Thirdly, the interrupting rating of the fuses within the disconnect must be adequate to safely interrupt any fault currents that may occur in the circuit. A common misconception is that a non-fused disconnect simply acts as an on or off switch. While it does serve that function, its primary purpose is to provide a means of disconnecting the motor from the power supply for maintenance or emergency situations. However, it does not provide any overcurrent protection. In contrast, a fused disconnect incorporates fuses that are designed to protect the motor and the branch circuit wiring from overloads and short circuits. These fuses are sized according to the motor's full load current and the applicable NEC requirements. When a motor is started, it draws a significantly higher current than its normal full load current. This is known as the inrush current or starting current. Fuses must be able to withstand this inrush current without opening, while still providing protection against sustained overloads or short circuits. The NEC specifies different types of fuses, such as time delay fuses and dual element fuses, that are designed to handle motor starting currents. Time delay fuses are designed to allow temporary overloads, such as motor starting currents, to pass without opening. They provide a time delay that allows the motor to start and reach its operating speed. Dual element fuses combine a time delay element with a current limiting element. The time delay element allows the motor to start, while the current limiting element provides fast protection against short circuits. The selection of the appropriate fuse type depends on the motor's characteristics and the specific application. Another important consideration is the motor starter. A motor starter is an electrical device that controls the starting, stopping, and protection of an electric motor. It typically includes overload relays that provide protection against motor overloads. If the motor is equipped with a motor starter that provides overload protection, a non-fused disconnect may be acceptable. However, it's important to verify that the motor starter is properly sized and installed according to the NEC requirements. In cases where the motor is not equipped with a motor starter or the motor starter does not provide adequate overload protection, a fuse disconnect is required. Fuses in the disconnect provide the necessary overcurrent protection to protect the motor and the branch circuit wiring. Furthermore, the NEC requires that the disconnect switch be readily accessible and located within sight of the motor. This allows personnel to quickly disconnect the motor from the power supply in case of an emergency. The disconnect switch must also be clearly labeled to indicate its purpose. The labeling should include the words motor disconnect or similar wording to clearly identify the switch. In addition to the NEC requirements, local electrical codes may have additional requirements for motor disconnects. It's important to check with the local authorities to ensure compliance with all applicable codes. For example, some local codes may require the use of specific types of disconnect switches or may have additional requirements for labeling or accessibility. When installing a motor disconnect, it's crucial to follow all manufacturer's instructions and safety precautions. The disconnect switch should be installed in a suitable enclosure that provides protection against environmental factors such as moisture and dust. The enclosure should also be properly grounded to ensure electrical safety. Before working on any electrical equipment, it's essential to energize the circuit by turning off the circuit breaker or removing the fuses. Verify that the circuit is de-energized using a voltage tester before proceeding with any work. It's also important to wear appropriate personal protective equipment, such as safety glasses and insulated gloves, to protect against electrical hazards. In summary, the decision to use a fused or non-fused disconnect for a drill press motor depends on several factors, including the presence of motor overload protection, the NEC requirements, and local electrical codes. If the motor lacks built-in overload protection, a fused disconnect is generally required to provide overcurrent protection. It's crucial to consult with a qualified electrician to ensure that the installation complies with all applicable codes and safety standards. By understanding the technical aspects of motor disconnects and following the proper installation procedures, you can ensure a safe and reliable electrical system for your drill press. Remember to always prioritize safety when working with electrical equipment. The NEC is updated regularly to reflect changes in technology and safety practices. Therefore, it's important to stay current with the latest edition of the NEC to ensure compliance with the most up-to-date requirements. Additionally, manufacturers of motor disconnects and motor starters provide valuable information and resources that can assist in the selection and installation of these devices. Consulting with these manufacturers can help ensure that you are using the appropriate products for your specific application. The proper grounding of electrical equipment is essential for safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker or blow the fuse, preventing electrical shock hazards. The NEC specifies the requirements for grounding electrical equipment, including motor disconnects and motor starters. It's important to follow these requirements to ensure that the electrical system is properly grounded. Regular maintenance of motor disconnects and motor starters is also important for ensuring their continued reliable operation. This maintenance may include inspecting the contacts for wear or corrosion, tightening connections, and testing the operation of the overload relays. By performing regular maintenance, you can help to prevent equipment failures and extend the lifespan of the electrical system. When replacing a motor disconnect or motor starter, it's important to select a replacement that is compatible with the existing electrical system. This includes verifying that the voltage rating, ampere rating, and interrupting rating of the replacement device are suitable for the application. It's also important to ensure that the replacement device is listed by a recognized testing laboratory, such as Underwriters Laboratories, to ensure that it meets safety standards. If you are unsure about any aspect of the installation or maintenance of motor disconnects or motor starters, it's always best to consult with a qualified electrician. A qualified electrician has the knowledge, skills, and experience to safely and properly install and maintain electrical equipment. They can also help you to comply with all applicable codes and safety standards. In addition to the technical aspects of motor disconnects, it's also important to consider the ergonomic aspects. The disconnect switch should be located in a convenient and easily accessible location. The switch should also be easy to operate even with gloves on. By considering the ergonomic aspects of motor disconnects, you can help to improve the safety and efficiency of the workplace. The selection of a motor disconnect should also take into account the environmental conditions in which it will be used. If the disconnect will be exposed to moisture, dust, or other environmental contaminants, it should be installed in a suitable enclosure that provides protection against these factors. The enclosure should also be rated for the appropriate environmental conditions, such as NEMA 4 for wet locations or NEMA 12 for dusty locations. The NEC provides guidelines for selecting enclosures for electrical equipment based on the environmental conditions. The use of variable frequency drives, or volts, to control motors is becoming increasingly common. Volts can provide energy savings and improve motor control. However, volts can also introduce harmonic currents into the electrical system. Harmonic currents can cause problems such as overheating of transformers and conductors. The NEC provides guidelines for mitigating harmonic currents in electrical systems. If a volt is used to control the drill press motor, it's important to ensure that the electrical system is properly designed to mitigate harmonic currents. The installation of a motor disconnect is a critical part of the electrical system. By following the proper installation procedures and complying with all applicable codes and safety standards, you can ensure a safe and reliable electrical system for the drill press. Remember to always prioritize safety when working with electrical equipment and to consult with a qualified electrician if you have any questions or concerns.